Now we're going to be finding not just the rational roots, but all the roots. We're still going to find the possible rational roots, but since this question doesn't have context like the last one did, the imaginary roots, we can still find them. Like, it's not like they're meaningless. So anyway, you're given the equation listing the factors of the constant, 1 and 2, plus or minus 1 and 2. Factors of the leading coefficient is plus or minus 1 and 3. So the possible rational roots are all of the red ones divided by all the blue ones. So you have plus or minus 1/3, 2/3, 1 and 2. So they're saying testing shows that 2/3 and positive 2/3 and negative 1 are rational roots. Again, I'm going to do that testing just by looking at the graph. You can do it however you want. When we do the try it example, that's how I'm going to do that part. Then just pick one of them. And 2/3 is the number you're going to try. You can actually do either one, doesn't matter, but they're choosing 2/3. Do synthetic division with what comes out of there. So see how these numbers become these numbers here. Now you do it with -1. What you're left with is 3, 3, and 3. So that means 3x squared plus 3x plus 3. You can factor the 3 out and just get it as x squared plus x plus 1. So your factor, and the 3 would stay out front if you're trying to get all the factors, but it's not going to help you. It's not going to be meaningful in terms of getting the zeros or the solutions. We now need to do quadratic formula with the quadratic that's left. And again, if you were to graph it, you would have seen that it's only crossing twice. And for a 4th degree polynomial, fundamental theorem of algebra says you should have 4 roots. So 2 of them are real, the other 2 are going to be imaginary. And when you use quadratic formula, you get that it's -1 plus or minus I√3 over 2. So the 4 roots are 2/3, -1, -1, minus I√3 over 2, and -1 plus I√3 over 2. And again, 1, 2, 3, 4, because it was a 4th degree. All right. So let me know if you have questions on that. Let's look at the try it example. So basically the exact same question. To do each of those things after you pause it, and then you come back and try it. So you're going to find the possible rational roots, figure out which ones are potentially the ones to use. So test it however you want. I'm going to graph. Then do synthetic division. This one's cubic, so there's only going to be 3 possible roots here. So we'll see how many times it's crossing to determine how many we think are going to be real and imaginary. And then once you have it down to a quadratic, then just use quadratic formula to get the other ones. All right, so yeah, pause it now and then come back and check. So with this one, list out the factors of -10, so plus or minus 1, 2, 5, and 10. Leading coefficient's 1, so it's just plus or minus 1. That's the easiest scenario. When there is no leading coefficient, it means it's 1. So then the possible rational roots are just the factors of the constant. So 1, 2, 5, 10, plus or minus. I went ahead and graphed it. Again, anything that's rational that was crossing would be between -10 and 10. So the only one that we're seeing is 2. So when I go back, that's the number I'm trying in synthetic division. What you end up with is x squared plus 5. So since that's got no linear term, instead of doing quadratic formula, I'm just going to solve it by taking square roots. If you did quadratic formula with it, you would get the same answer. It's just going to be more work. So when there is no linear term, just do square roots because it's faster. So you subtract 5, take a square root, and you get plus or minus I√5. So the 3 roots are 2, I√5, negative I√5. When I graphed it, I could see it's only crossing one place as well. So I knew the other 2 roots had to be imaginary, right? Because there's got to be 3 total because the function was a cubic. So I knew there was going to be 3 roots. So you got 1 real, 2 imaginary. All right, let's look at the 4th example.